Hello, sleepy soul. Welcome to this quiet journey through the cosmos. If you are listening to this now, in the stillness of your room, perhaps with the lights dimmed or the screen turned away, let yourself settle into this moment. There is nothing you need to do, nothing to solve or remember. You are simply here, and that is enough. Tonight, we will travel together, not through space exactly, but through the idea of space. We will explore what it means for light to move, for distances to exist, and for time to stretch across the dark. And as we do, you might find your thoughts beginning to slow, your breathing deepening, your body growing heavier and warmer. Let your eyes rest. Let your shoulders drop. You do not need to follow every word. The universe is patient. It has been here for billions of years, and it will wait for you. So breathe in slowly and breathe out, and let us begin our gentle departure from this small, warm world. We live on a planet that feels large to us. Oceans stretch for thousands of miles. Mountains rise into the sky. Cities spread across continents. And yet, in the grand architecture of the cosmos, Earth is a pale blue, suspended in a sunbeam, as one poet of science once described it. To understand the universe, we must first understand how far apart things truly are. And to understand distance, we must understand the one thing that connects all of space and time, the universal constant that governs everything we see and everything we will never see. Light. Light is fast. Faster than anything we know. Faster than sound. Faster than the fastest rocket, faster than thought itself, it seems. And yet, for all its speed, light is also slow. Impossibly, maddeningly slow when measured against the distances of the cosmos. Tonight, we will learn what it means for light to travel. We will feel the weight of emptiness. And we will understand, in a quiet and gentle way, just how alone and how connected we are in this vast, dark sea of space. Light travels at approximately 300,000 kilometers per second. In miles, that is about 186,000 miles every single second. If you could move at the speed of light, you could circle the Earth 7.5 times in just 1 second. Imagine that for a moment. 7.5 times around the world in one heartbeat. It sounds impossibly fast, and it is. Nothing in the universe can travel faster than light. It is the ultimate speed limit, written into the fabric of reality itself. Particles, waves, information, all of it obeys this law. 300,000 kilometers per second. No more, no less. But here is the paradox. Here is a quiet truth that we will explore tonight. While light is the fastest thing we know on the scale of the cosmos, it is achingly, beautifully slow. Let us begin with something close to home. The moon. The moon hangs in our sky, soft and silver, sometimes full, sometimes crescent, always familiar. It feels near, does it not? You can see it with your naked eye. It seems within reach. And yet, the moon is about 384,000 kilometers away from Earth. When you look at the moon tonight, the light you see the gentle glow reflecting off its surface. That light left the moon 1.3 seconds ago. You are not seeing the moon as it is now. You are seeing the moon as it was just over a second in the past. Light from the moon takes 1.3 seconds to reach your eyes. This is the beginning of what astronomers call light travel time. It is a delay between an event and our perception of it. Now let us travel farther. Let us consider the sun. The sun sits at the center of our solar system, a massive ball of burning hydrogen and helium, holding us in its gravitational embrace. It is about 150 million kilometers away. This distance is so common in astronomy that we have given it a name. We call it 1 astronomical unit, or 1 AU. Light from the sun takes 8 minutes and 20 seconds to reach Earth. Think about that. When you step outside and feel the warmth of sunlight on your face, you're feeling something that left the sun more than 8 minutes ago. The sun you see is the sun as it was 8 minutes in the past. If the sun were to suddenly vanish, we would not know for 8 minutes and 20 seconds. We would continue to see it, shining in the sky, as though nothing had changed. Only after that delay would the sky go dark. This is the nature of light. This is the speed limit of the cosmos. Even at 300,000 kilometers per second, light takes time to travel. And the farther we look, the longer the delay becomes. Let us now travel to Mars, the red planet. The fourth world from the sun, Mars, has fascinated humanity for centuries. We have sent rovers to its surface, orbiters to circle its skies. We dream of one day walking on its rust-colored dunes. But Mars is far. Depending on where Earth and Mars are in their orbits, the distance between the two planets varies. At its closest, Mars is about 55 million kilometers away. At its farthest, it is more than 400 million kilometers distant. On average, Mars is roughly 225 million kilometers from Earth. And this creates a very strange problem for anyone trying to communicate with Mars. Imagine you are an astronaut on Mars. You are standing on the surface, looking up at the pale dot of Earth in the Martian sky. You pick up your radio and say, "Hello, how long does it take for that message to reach Earth?" Radio waves, like light, travel at the speed of light. They are, in fact, a form of light, just at a different wavelength. So your message, traveling at 300,000 kilometers per second, takes about 12 and a half minutes to reach Earth when the planets are at an average distance. And then, if someone on Earth replies immediately, their response takes another 12 and a half minutes to travel back to you. In total, a round-trip conversation with Mars takes about 25 minutes. 25 minutes between saying hello and hearing a reply. This is what we call radio silence. This is the loneliness of space. You cannot have a conversation with someone on Mars the way you can have a conversation with someone on Earth. There is no back and forth, no quick exchange of words, only waiting, only patience. When the Mars rovers send images back to Earth, those images are already 12 and a half minutes old by the time we see them. When engineers send commands to a rover, They must wait 12 and a half minutes for the rover to receive the command, and then another 12 and a half minutes to know if the command was successful. This is the reality of cosmic distances. This is the weight of emptiness. Even our nearest planetary neighbor requires us to slow down, to think carefully, to accept delay. To truly understand the distances in our solar system, we must visualize the space between things. And there is a remarkable fact that helps us do this. A fact about the moon and the planets. If you were to line up all the planets in our solar system, Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, and place them in a straight line, they would fit in the space between the Earth and the Moon, with room to spare. Let that sink in for a moment. The distance from Earth to the Moon is 384,000 kilometers. The combined diameters of all the planets in our solar system add up to about 380,000 kilometers. They would fit edge to edge in that single gap. This tells us something profound about space. It tells us that space is mostly nothing, mostly void, mostly silence. When we look at images of the solar system in textbooks, the planets are drawn close together for convenience. But in reality, they are separated by enormous gulfs of emptiness. If the sun were the size of a basketball, Earth would be a grain of sand 26 meters away. Jupiter would be a marble 133 meters away. And Neptune, the farthest planet, would be almost 800 meters distant. In between these tiny grains and marbles, nothing, just empty space, cold, dark, and silent. This emptiness is not a flaw. It is not something to fear. It is simply the architecture of the cosmos. Space is generous with its distances. It gives things room to exist, room to orbit, room to be, and light, traveling at its constant speed, takes hours to cross from one side of this emptiness to the other. Light from the sun takes about 4 hours to reach Neptune. For hours of traveling at 300,000 kilometers per second, and it still has not left our solar neighborhood. In 1977, humanity launched 2 spacecraft into the void. They were called Voyager 1 and Voyager 2. Their mission was to explore the outer planets, Jupiter and Saturn, Uranus and Neptune, to send back images and data from worlds we had never seen up close. And they succeeded. Voyager 1 flew past Jupiter and Saturn, capturing breathtaking images of swirling storms and icy moons. Voyager 2 continued on, becoming the only spacecraft to visit Uranus and Neptune. Together, they transformed our understanding of the outer solar system. But their journey did not end there. After completing their planetary tours, the Voyager spacecraft kept going. They traveled beyond the orbit of Pluto, beyond the scattered debris of the Kuiper Belt, into a region of space we call the heliosheath, the boundary where the sun's influence begins to fade. Voyager 1 is now the farthest human-made object from Earth. As of today, it is more than 15 billion miles away. That is roughly 24 billion kilometers. Or, in astronomical terms, about 165 times the distance from the Earth to the Sun. it has been traveling for nearly 50 years. 50 years of moving through the void, powered by a small nuclear battery, sending faint radio signals back to Earth. And yet, for all that distance, for all that time, Voyager 1 has barely left our cosmic front yard. The nearest star to our sun, other than the sun itself, is called Proxima Centauri. It is about 4.2 light years away. A light year is the distance light travels in 1 year, which is roughly 9.5 trillion kilometers. Proxima Centauri is 4.2 light years distant. Light from that star takes 4.2 years to reach us. And Voyager 1, traveling at about 17 kilometers per second, will take approximately 40,000 years to pass near a star at that distance. 40,000 years. Think about that. Humanity has existed in its current form for perhaps 200,000 years. Recorded history goes back only about 5,000 years. And Voyager will take 40,000 years just to reach the neighborhood of the nearest star. This is the scale of interstellar space. This is what we mean when we say the cosmos is vast. Voyager 1, our fastest, most distant ambassador, is moving through an ocean so large that our lifetimes, our civilizations, our entire history as a species are but brief flickers. And yet, Voyager continues. It carries with it a golden record, a time capsule of Earth. On that record are sounds and images of our world, music, greetings in different languages, the sound of a mother's heartbeat. It is a message in a bottle cast into the cosmic sea. Voyager may never be found. It may drift through the void forever, silent and alone. But it is there nonetheless, a testament to our curiosity, a symbol of our desire to reach beyond ourselves, to touch the infinite. So we return now to where we began, to the idea of light and distance and time. Light travels at 300,000 kilometers per second, fast beyond comprehension, and yet slow against the vastness of space. Light from the moon takes 1 second. Light from the sun takes 8 minutes. Light from Mars takes 12 minutes. Light from the nearest star takes 4 years. We live in a universe where distance matters, where separation is built into the very fabric of existence. And perhaps there is something comforting in that. Perhaps there is peace in knowing that we are small, that our world is a quiet corner of something much larger. The cosmos does not rush. It moves at the speed of light, which is both the fastest and somehow the slowest speed there is. It asks us to be patient, to accept that some things take time, to understand that distance is not emptiness, but presence of a different kind. And so, as you rest tonight, as your thoughts begin to dissolve into dreams, imagine yourself on that journey. Imagine you are light, leaving the sun, traveling across the empty miles, moving through the dark with perfect constancy. You pass the moon in just over a second. You pass the Earth in 8 minutes. You pass Mars and Jupiter and Saturn, each world a small, silent companion in the void. You travel for hours, for days, for years. And still, There's only darkness and distance and the quiet hum of your own movement. And that is okay. That is the universe. Patient, vast, gentle in its enormity. Let yourself drift now. Let the distances stretch. Let the light carry you. There is no hurry. There's only the slow, steady rhythm of the cosmos, breathing in and out, moving through its endless night. Rest well, traveler. The universe is patient, and so can you be. We continue now, deeper into the night, deeper into the cosmos. You have traveled with light across the solar neighborhood. You have felt the distances between worlds. And now we will pull back. We will lift ourselves higher until our sun becomes just one star among hundreds of billions. Let your breathing remain slow and steady. Let your body sink a little deeper into comfort. There is no need to hold tension anywhere. Your jaw can soften. Your hands can rest. The galaxy is patient. It has been turning for billions of years, and it will continue to turn long after this night has passed. Tonight, we will explore the Milky Way, our galactic home. We will learn about its shape, its structure, and our place within it. We will visit the quiet suburbs where we live, the brilliant nurseries where stars are born, and the ancient center where gravity itself bends light. And as we do, you may notice your thoughts becoming softer, your awareness drifting like dust in a sunbeam. That is okay. That is perfect. Let yourself wander. The Milky Way is vast enough to hold all of your dreams. On a clear night, far from the lights of cities, you can see a band of pale light stretching across the sky. The ancient Greeks called it galaxias kyklos, the Milky Circle. We know it now as the Milky Way. What you are seeing is not a cloud. It is not mist. It is a combined light of billions upon billions of stars, so distant that they blur together into a soft, glowing river. You're looking at your own galaxy from the inside, edge on, like standing in a vast city and looking down a long, illuminated avenue. The Milky Way is a spiral galaxy. Imagine a great pinwheel, slowly turning in the void. It has arms that curve outward from a bright, dense center, arms made of stars and gas and dust, all swirling in a cosmic dance that takes 200 million years to complete a single rotation. We live in one of those arms, not at the center, where stars are packed tightly together, but farther out in a quieter region, a place where there is room to breathe, room for planets to form, room for life to unfold. Our solar system resides in what astronomers call the Orion Arm, sometimes known as the Orion Spur. It is a minor arm of the Milky Way, a smaller branch that extends between two larger spiral arms, the Perseus Arm and the Sagittarius Arm. Think of it as living in the suburbs of a great galactic city. The center of the Milky Way is the downtown, bright and crowded, filled with millions of stars packed into a relatively small space. There, the night sky will be dazzling, filled with brilliant lights, so many that darkness will be almost unknown. But we do not live there. We live farther out, in a quieter district. Here, the stars are spaced farther apart. The distances between them are measured in light years, not light months. Our nearest stellar neighbor, Proxima Centauri, is more than 4 light years away. In the galactic center, stars can be separated by mere light weeks. This distance is not a disadvantage. It is a gift. In the crowded center, gravitational interactions are frequent. Stars pass close to one another, their gravity tugging at planets, disrupting orbits. Supernovae, the explosive deaths of massive stars, occur more often. Radiation levels are higher, but here, in the Orion Arm, we have stability. Our sun has been shining steadily for nearly 5 billion years, undisturbed by close stellar encounters. The Earth has had time to cool, time for oceans to form, time for life to begin and evolve and flourish. We live in the suburbs, yes, but the suburbs are peaceful. They are safe. They are a place where complexity can grow, where delicate things can survive. The Orion Arm stretches for about 3,500 light years. It is filled with young, hot stars, stars that burn blue and white, stars that formed relatively recently in cosmic terms. Our sun is older, a middle-aged yellow star, settling into a long, stable existence. From our vantage point in the Orion Arm, we are about 26,000 light years from the galactic center. That means if you could look toward the center and see it clearly, you would be seeing light that left there 26,000 years ago, when humans on Earth were just beginning to create art in caves. We orbit the galactic center at a speed of about 220 kilometers per second. This sounds fast, but the Milky Way is so large that it takes our solar system approximately 230 million years to complete one full orbit. We call this a galactic year. In the entire history of Earth, our planet has completed only about 20 galactic years. When the dinosaurs walked the Earth, we were in a slightly different part of the galaxy. When the first single-celled organisms appeared, we were on the opposite side of the Milky Way. This is the rhythm of the galaxy. Slow, patient, turning like a great wheel, carrying us along in its quiet rotation. Stars are not eternal. They are born, they live, and eventually they die. And the places where stars are born are among the most beautiful structures in the universe. We call them stellar nurseries. We call them nebulae. These are vast clouds of gas and dust, spread across light years of space, glowing softly with the light of newborn stars. One of the most famous stellar nurseries is the Eagle Nebula, located about 7,000 light years from Earth. Within this nebula are structures known as the Pillars of Creation, towering columns of gas and dust that stretch for several light years. Imagine pillars so tall that light takes years to travel from their base to their tip. Imagine columns of matter, dark and cool, silhouetted against the glow of the nebula behind them. They look like the spires of a great cathedral, reaching upward into the cosmic vault. And that is precisely what they are. Cosmic cathedrals, places of creation. Inside these pillars, gravity is slowly pulling the gas and dust together. Clumps form, they grow denser, and as they collapse, they heat up, Eventually, the core becomes so hot and so dense that hydrogen atoms begin to fuse together, releasing tremendous amount of energy. A star is born. It ignites, and its light pushes back against the surrounding cloud, carving out a space for itself. This process takes millions of years. It is slow. It is gentle. The pillars do not collapse all at once. They erode slowly, sculpted by the light and wind from nearby young stars. The pillars of creation are just one example. There are countless stellar nurseries scattered throughout the Milky Way. The Orion Nebula, visible to the naked eye as a fuzzy patch in the constellation Orion, is one of the closest star-forming regions to Earth, only about 1,300 light-years away. Inside the Orion Nebula, thousands of stars are being born. Young, hot stars illuminate the surrounding gas, making it glow in shades of red and pink and blue. It is a stellar cradle, a place of constant, quiet creation. These nebulae are made mostly of hydrogen, the simplest and most abundant element in the universe. Mixed in are heavier elements, carbon, oxygen, iron, silicon, elements that were forged in the hearts of previous generations of stars and scattered into space when those stars died. So when a new star forms, it is built from the ashes of old stars. And when planets form around that star, they too carry the legacy of ancient suns. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was forged in stars that lived and died billions of years ago. You are made of stardust. Literally, every atom in your body was once part of a star. And when you look up at a nebula, you are looking at the birthplace of future worlds, future life, future dreams. The nebulae glow softly. They do not shout. They do not demand attention. They simply are vast and patient, sculpting new suns in the silence of space. At the very heart of the Milky Way, hidden behind vast clouds of dust and gas, lies an object of immense power. It is called Sagittarius A star, written as Sagittarius A asterisk. It is a supermassive black hole. Black holes are often described as monsters, cosmic predators that devour everything nearby. But this is not the full story. Sagittarius A star is not a destroyer. It is an anchor. It is the gravitational heart that holds our entire galaxy together. Sagittarius A star has a mass of about 4 million times that of our Sun. And yet, despite this enormous mass, it occupies a space no larger than the orbit of Mercury. All of that matter compressed into a region so small and so dense that not even light can escape its gravity. This is what defines a black hole. It is a place where gravity is so strong that the escape velocity exceeds the speed of light. And since nothing can travel faster than light, nothing that crosses the event horizon, the boundary of the black hole, can ever return. But from a distance, Sagittarius A star is not dangerous. It does not reach out and pull things in from across the galaxy. Its gravity follows the same laws as the gravity of any other massive object. If you were to replace the Sun with a black hole of the same mass, the Earth would continue to orbit exactly as it does now, Gravity depends on mass and distance, not on whether the object is a star or a black hole. What Sagittarius A star does is provide a gravitational center for the galaxy. Just as the sun holds the planets in orbit, Sagittarius A star helps hold the stars of the Milky Way in their slow, sweeping paths. Stars near the galactic center orbit Sagittarius A star at tremendous speeds. Astronomers have tracked individual stars as they loop around the black hole, some completing an orbit in just a few years. These stars move so fast that their motion is visible over the course of months, a rare thing in astronomy, where most changes take lifetimes to observe. By watching these stars, scientists have confirmed that Sagittarius A star is indeed a black hole, and they have measured its mass with extraordinary precision. It sits there, silent and invisible, its presence known only by its gravitational influence on the object around it. Most supermassive black holes at the centers of galaxies are active. They pull in gas and dust from their surroundings, and as that matter spirals inward, it heats up, releasing enormous amounts of energy. These active black holes shine brighter than entire galaxies, visible across billions of light years. But Sagittarius A star is quiet. It is dormant. It consumes very little material. It does not blaze. It does not roar. It simply exists, a deep well of gravity at the center of our galactic home. In a way, this is fitting. The Milky Way is a quiet galaxy. It is not colliding with another galaxy. It is not undergoing violent star formation. It is simply turning slowly, generation after generation, its stars moving in their ancient rhythms. And at the center, Sagittarius A star holds it all together, not through force, but through the simple, steady pull of gravity. It is the anchor, the axis, the still point around which the galaxy turns. Let us return for a moment to the idea of time. We have spoken of light years, the distance light travels in a year. But there is another unit of time worth considering, the galactic year. A galactic year is the time it takes for our solar system to complete one full orbit around the center of the Milky Way. As we mentioned, this takes about 230 million Earth years. Think about what this means. Our sun has orbited the galaxy only about 20 times since it formed. In all the billions of years of the sun's existence, it has made only 20 trips around the galactic center. When the sun was young, when the solar system was just forming, we were in a different part of the galaxy. We have drifted through different stellar neighborhoods. We have passed near different stars, different nebulae, different clusters. And yet, throughout all of this, the basic structure of the galaxy has remained the same. The spiral arms continue to turn. The black hole at the center continues to anchor. New stars are born in the nebulae, and old stars die, enriching the interstellar medium with heavy elements. The galaxy breathes. It cycles. It renews itself. And we are part of that cycle. We are passengers on a small, rocky world, orbiting an ordinary star, which itself is orbiting the galactic center, which itself is moving through the universe along with billions of other galaxies. It is dizzying if you think about it too hard. But it is also calming, because it reminds us that we are part of something much larger. We are not separate from the cosmos. We are within it. We are of it. So we rest here, for now, in the Orion arm of the Milky Way, 26,000 light-years from the center, moving at 220 kilometers per second through the galactic suburbs. We are surrounded by nebulae, those cosmic cathedrals where stars are born. We are held in orbit by the gentle gravity of Sagittarius A star, the anchor at the heart of our galaxy. We live in a quiet neighborhood, far from the crowded center, far from the chaos of colliding galaxies. We have stability. We have time. We have the gift of distance. And perhaps that is the greatest lesson of the Milky Way, that there is a place for everything, that the suburbs are not lesser than the city. That quiet can be a kind of richness. As you drift now, as your thoughts dissolve into the soft fabric of sleep, imagine yourself floating above the galactic plane. Look down at the spiral arms, glowing softly in the dark. See the bright center, where millions of stars cluster together. See the nebulae scattered like jewels throughout the arms. And there, in the Orion arm, see a small yellow star, our sun home, a tiny point of light among billions, and yet for us, the center of everything. The galaxy turns. The stars are born. The black hole holds steady. And you, resting now, are part of it all. Sleep well, traveler. The Milky Way will still be here when you wake. It has been turning for 13 billion years. It can wait another night. We have traveled far together, from the solar neighborhood to the Milky Way, from our small sun to the heart of our galaxy. And now, we will step back even farther. We will leave the Milky Way behind, pulling away until it becomes just one island of light among many. Let yourself settle deeper now. Your breathing is slow. Your body is heavy and warm. There is nothing you need to hold on to. The universe will carry you. It always has. Tonight, we will explore the local group, the small collection of galaxies to which the Milky Way belongs. We will meet Andromeda, our sister galaxy, drifting slowly toward us across the void. And we will learn about the space between galaxies, the vast, empty reaches where silence is absolute. As we journey through this quiet darkness, you may find your thoughts becoming distant, like stars seen through fog. That is perfect. That is exactly where you should be. Let go. Drift. The cosmos is patient. Galaxies are not scattered randomly throughout the universe. They gather in groups, held together by gravity. Some groups are small, containing just a few galaxies. Others are enormous clusters, containing thousands of galaxies, each with billions of stars. The Milky Way belongs to a small group. We call it the local group. It contains about 50 galaxies, though most of them are small, faint dwarf galaxies. Only 3 are large spiral galaxies: the Milky Way, Andromeda, and Triangulum. The local group is about 10 million light years across. This sounds vast, and it is, but in the context of the universe, It is a small neighborhood, a quiet corner, a place where a few galaxies orbit one another in a slow, gravitational dance. And beyond the local group, there is emptiness. Vast, dark, silent emptiness. The space between galaxy groups is the truest void in existence. A place where atoms are so rare that you might travel for light years without encountering a single one. On a clear autumn night, if you know where to look, you can see a faint smudge of light in the constellation Andromeda. It looks like a small, hazy cloud, but it is not a cloud. It is a galaxy, the Andromeda Galaxy. Andromeda is the nearest large galaxy to the Milky Way. She is about 2.5 million light years away. This means the light you see when you look at Andromeda left that galaxy 2.5 million years ago, when early humans were just beginning to walk upright on the plains of Africa. Andromeda is slightly larger than the Milky Way. She contains about 1 trillion stars, compared to our 300 billion. Her spiral arms stretch across 220,000 light years of space. If you could see her edge-on, she would appear 6 times wider than the full moon in our sky. But from our vantage point, we see Andromeda tilted at an angle. We see the graceful curve of her spiral arms, the bright core at her center, the dark lanes of dust winding through her structure. She is beautiful, majestic, a sister to our own galaxy, and she is moving. Andromeda is drifting toward us. This might sound alarming. A galaxy heading in our direction, but there is no need for concern. The universe moves slowly. Galaxies are patient. Andromeda is approaching the Milky Way at a speed of about 110 kilometers per second. This is fast by human standards. But remember the distance. 2.5 million light years. At this speed, Andromeda will take approximately 4.5 billion years to reach us. For 0.5 billion years. To put this in perspective, the Earth is 4.5 billion years old. The same amount of time that has passed since our planet formed will pass again before the Milky Way and Andromeda come together. And when they do meet, it will not be a violent crash. It will be a slow-motion cosmic dance. Galaxies are mostly empty space. Stars are separated by vast distances. When two galaxies merge, the stars themselves rarely collide. They pass by one another, threading through like dancers in a choreographed performance. Gravity will pull the two galaxies together. Their spiral arms will stretch and distort. Gas clouds will collide, triggering bursts of new star formation. The supermassive black holes at the center of each galaxy will eventually spiral inward and merge, creating a single, larger black hole. Over billions of years, the Milky Way and Andromeda will become one galaxy. Astronomers have even given this future galaxy a name. Milkomeda, a blend of the two names, a new structure born from the union of two ancient spirals. But this is so far in the future that it is almost impossible to imagine. By the time Andromeda arrives, the sun will have already entered its final stages of life. It will have swelled into a red giant, engulfing the inner planets. The Earth, if it still exists, will be a charred, lifeless rock. And yet, even in that distant future, new stars will be born in Milkomeda. New planets will form. New possibilities will emerge. The universe does not end. It transforms. For now, Andromeda drifts toward us, a gentle presence in the night sky, a reminder that even galaxies are not isolated. Even across millions of light years, gravity connects. Even in the vastness of space, there are companions. Andromeda is not our only neighbor. The local group contains dozens of smaller galaxies, scattered throughout the space around the Milky Way. The closest of these are the Magellanic Clouds, two irregular dwarf galaxies visible from the southern hemisphere of Earth. The Large Magellanic Cloud is about 160,000 light-years away. The Small Magellanic Cloud is about 200,000 light-years distant. These small galaxies orbit the Milky Way, bound us by gravity. They are satellites, like moons around a planet, but on a galactic scale. Over billions of years, they will slowly spiral inward, eventually merging with the Milky Way. The Triangulum Galaxy is the third largest member of the local group, after the Milky Way and Andromeda. It is about 3 million light-years away, a small spiral galaxy with roughly 40 billion stars. It is fainter than Andromeda, harder to see, but it is there, another island of light in the cosmic ocean. Most of the other galaxies in the local group are dwarf galaxies. They contain only a few million or a few billion stars. They are faint, difficult to detect, hidden in the glow of brighter galaxies. But they are real, each one a small community of stars, orbiting through the darkness. Some of these dwarf galaxies are elliptical, shaped like smooth, featureless blobs. Others are irregular, with no clear structure, just loose collections of stars and gas. They are the quiet members of our cosmic neighborhood, easy to overlook, but part of the family nonetheless. Together, these galaxies form the local group, a small cluster bound by gravity, moving through the universe as a unit. We are not alone. Even on the scale of galaxies, there is community. Between the galaxies, there is space. Not the space between stars, which is filled with tenuous gas and dust. Not the space between planets, which is traversed by light and solar wind. This is different. This is the intergalactic void. The intergalactic void is the truest vacuum in the universe. It is emptier than the vacuum of space near Earth, emptier than the space between stars, emptier than any vacuum we can create in a laboratory. In the space between galaxies, there are fewer than 1 atom per cubic meter. To understand how empty this is, consider that the air you breathe contains about 25 quintillion molecules per cubic meter. The vacuum of space near Earth contains about 10 million particles per cubic meter. The space between stars contains about 1 million particles per cubic meter. But in the intergalactic void, there is less than 1 atom per cubic meter. Sometimes, there are no atoms at all for many cubic meters. It is a place of profound emptiness. This is not a flaw. This is not a lack. This is simply the architecture of the universe. Space is generous. It gives things room. Room to exist. Room to move. Room to be. In the intergalactic void, there is no sound. Sound requires a medium to travel through, molecules to vibrate. But with fewer than 1 atom per cubic meter, there is no medium. There is nothing to carry a wave. Silence is absolute. If you could somehow exist in the intergalactic void, floating between galaxies, you'd see darkness in every direction. The nearest stars would be millions of light years away, so faint that they would be invisible to the naked eye. You would see only the distant smudges of galaxies, glowing softly like candles seen through fog, and you would feel nothing. No warmth from any star. No radiation, no light, no heat. The temperature in the intergalactic void is just a few degrees above absolute zero, the coldest possible temperature. This might sound terrifying. Absolute cold, absolute darkness, absolute silence. But there is another way to think about it. The intergalactic void is a place of perfect stillness, a place where nothing disturbs, nothing demands, nothing interrupts. It is the quietest place in the universe. Not quiet in the sense of soft sounds, but quiet in the sense of absence. No particles colliding, no light scattering, no vibrations, no waves, no disturbances of any kind. It is peace, pure, absolute peace. Of course, this emptiness is not complete. Even in the intergalactic void, there are things we cannot see. Dark matter, the mysterious substance that makes up most of the mass of the universe, permeates even the voids. Its gravity shapes the large-scale structure of the cosmos, pulling galaxies together into clusters and superclusters. And there is dark energy, the even more mysterious force that is causing the universe to expand at an accelerating rate. Dark energy fills all of space, even the voids, pushing galaxies apart, stretching the fabric of the universe itself. But these things do not disturb the silence. Dark matter and dark energy do not emit light. They do not make sound. They simply are invisible presences shaping the cosmos in ways we are only beginning to understand. The galaxies in the local group are not stationary. They are moving, drifting through space, held together by the invisible threads of gravity. Andromeda drifts toward us at 110 kilometers per second. The Magellanic Clouds orbit the Milky Way. Triangulum, too, is in motion, though its path is less certain. All of these galaxies are part of a slow gravitational ballet. On human timescales, these motions are imperceptible. Even over thousands of years, the positions of galaxies in the sky barely change. But over millions of years, over billions of years, the dance becomes visible. Galaxies approach. They orbit. They merge. This is the rhythm of the universe. Slow, patient, unhurried. Nothing happens quickly on cosmic scales. Everything takes time. Billions of years. Trillions of years. Time that is almost impossible for us to comprehend. And yet, the universe moves. It is not static. It is not frozen. It evolves. It changes. It dances. The local group will not exist forever. In the distant future, billions of years from now, the Milky Way and Andromeda will merge. The smaller galaxies will be absorbed. A new, larger galaxy will form, and it will drift through the intergalactic void, surrounded by silence, carrying within it the legacy of all the stars that came before. So we rest here, for now, in the local group, a small cluster of galaxies, floating in the vast intergalactic void. We are isolated. Yes, the nearest large galaxy cluster is tens of millions of light years away. But we are not alone. We have Andromeda, drifting slowly toward us, a sister across the void. We have the Magellanic Clouds, small companions orbiting our galaxy. We have Triangulum and dozens of dwarf galaxies, each one a small light in the darkness. And between us, there is silence, the truest vacuum, the quietest place in the universe, a space so empty that it defies imagination, and yet so peaceful that it invites contemplation. Perhaps there is a lesson here, that isolation and connection are not opposites, that distance does not mean separation, that even across millions of light years, gravity connects. Even in the deepest void, we are part of something larger. As you drift now, as your mind dissolves into sleep, imagine yourself floating in the intergalactic void. Darkness surrounds you. Silence envelopes you. You are alone, and yet you are not afraid. In the distance, you see the faint glow of galaxies. The Milky Way, a soft spiral. Andromeda, approaching slowly, patiently, across the eons. Triangulum, a small light, and all around, the quiet presence of dark matter, holding everything together in its invisible embrace. There is no rush. There is no urgency. The galaxies drift. The void waits. And you, suspended in this perfect stillness, can finally rest. Sleep well, traveler. The local group will still be here when you wake. It has been drifting for 13 billion years. It can wait another night. We have traveled so far together, you and I, from the warmth of our sun to the spiral arms of the Milky Way, from the local group to the intergalactic void, and still we have only glimpsed the smallest corner of the cosmos. Let your body sink deeper now. Let your thoughts become like water, flowing slowly, finding their own level. There is no need to hold anything. The universe holds you. It always has. Tonight, we will pull back even farther. We will see the largest structures in the universe, the superstructures, the immense architecture that gives shape to everything. We will discover that we live in something called Laniakea, a name that means immeasurable heaven. And we will learn that the universe is not random, but woven like a great cosmic web. As we drift through these vast scales, you may find yourself losing track of where you are. That is perfect, That is exactly where you should be. Let yourself dissolve into the immensity. The cosmos is patient. It will hold you gently. When astronomers first began to map the universe beyond our galaxy, they expected to find galaxies scattered randomly through space, like stars scattered across the night sky. But as they gathered more data, as they charted the positions of millions of galaxies, they discovered something extraordinary. The universe is not random. It has structure. Galaxies are not scattered evenly. They cluster together in groups. Those groups join into larger clusters. And those clusters form even larger structures called superclusters. And when you step back far enough, when you look at the universe on the largest scales, you see a pattern, a web, a delicate, intricate network of filaments and voids stretching across billions of light years. This is a cosmic web, and we are part of it. The Milky Way is part of the local group. The local group is part of a larger structure called the Virgo supercluster. And the Virgo supercluster is part of an even larger structure, a supercluster of superclusters called Laniakea. Laniakea is a Hawaiian word. It means immeasurable heaven. The name was chosen by astronomers to honor the Pacific Ocean navigators who used celestial knowledge to cross vast distances, guided by the stars. And it is a fitting name because Laniakea is truly immeasurable. Laniakea stretches across 520 million light years. It contains approximately 100,000 galaxies. Each of those galaxies contains hundreds of billions of stars. Each star may have planets. And on some of those planets, perhaps there is life, looking up at their own night sky, wondering if they are alone. The Milky Way, our home, is just one tiny point in this vast structure, a single galaxy among 100,000, a speck of light in the immeasurable heaven. Laniakea is not held together by a single force. It is defined by motion. All the galaxies within Laniakea are moving, flowing together like water in a great cosmic river. They are being pulled by gravity toward a common center, a region of unusually high mass. This flow of galaxies is slow, almost imperceptible. Galaxies move at hundreds of kilometers per second, but across millions of light years, this seems like a gentle drift, a slow current, a river that takes billions of years to flow. To map Laniakea, astronomers had to measure the motion of thousands of galaxies. They looked at how galaxies are moving relative to the overall expansion of the universe. Some galaxies are moving toward us. Some are moving away. By charting these motions, they could trace the flow, like mapping ocean currents by watching how debris drifts. And what they found was beautiful. Laniakea has boundaries, not walls, but regions where the flow of galaxies changes direction. Beyond those boundaries are other superclusters with their own flows, their own rivers of galaxies moving toward their own centers. We live in Laniakea, the Milky Way, the local group, the Virgo supercluster. All of it is part of this immense structure, and we are moving, drifting slowly with millions of other galaxies, carried along by the invisible hand of gravity. When you look at a map of the universe on the largest scales, you see something remarkable. Galaxies are not scattered randomly. They form patterns, lines, filaments, walls, and between these structures, there are vast empty regions called voids. This pattern is called the cosmic web. It looks in some ways like a spider's web, with threads of light stretching across darkness. It looks like a neural network, with nodes connected by pathways. It looks like foam, with bubbles of emptiness surrounded by thin walls of matter. The filaments of the cosmic web are made of galaxies, thousands of galaxies, strung together in chains that stretch for hundreds of millions of light years. These are the largest structures in the universe. Nothing is bigger. Nothing is more vast. But the galaxies are not what create the web. They are simply markers, lights that reveal the underlying structure. The true scaffolding of the cosmic web is dark matter. Dark matter is a mysterious substance. We cannot see it. It does not emit light or absorb light. It does not interact with ordinary matter except through gravity. And yet, it makes up about 85% of all the matter in the universe. Dark matter is invisible, but its effects are not. Its gravity shapes the universe. It pulls galaxies together. It holds galaxy clusters in place. And on the largest scales, it forms the filaments of the cosmic web. In the early universe, just after the Big Bang, matter was distributed almost evenly throughout space. Almost, but not quite. There were tiny variations in density, small regions where matter was slightly more concentrated than elsewhere. Over billions of years, gravity amplified these variations. Regions with slightly more matter attracted even more matter. They grew denser, and the regions in between grew emptier. Eventually, this process created the cosmic web. Matter flowed along gravitational pathways, like water flowing downhill, collecting into filaments and nodes. Galaxies formed along these filaments, lighting them up like streetlights along a highway. The void between the filaments are not completely empty. They contain a few stray galaxies, some dark matter, and the ever-present dark energy. But they are vast. Some voids are hundreds of millions of light years across. They are the empty spaces in the foam, the gaps in the web. The cosmic web is not static. It is evolving. Over time, the filaments are becoming more pronounced. Galaxies continue to flow along them, drawn by gravity toward the densest regions. And the voids are becoming emptier as matter drains out of them. This structure, this web, is the largest pattern in nature. It is the shape of the universe. And it is beautiful, delicate, intricate, a lace of light stretched across the darkness. Within Laniakea, there is a region that astronomers call the Great Attractor. It is not a single object. It is a gravitational anomaly, a region of space with an unusually high concentration of mass. The Great Attractor is pulling. It is pulling the Milky Way. It is pulling the local group. It is pulling the entire Virgo supercluster. It is pulling millions of galaxies, all flowing together in a great cosmic river. This pull is gentle. It does not yank. It does not tear. It is a slow, steady influence guiding galaxies along their paths. The Milky Way is moving toward the Great Attractor at a speed of about 600 kilometers per second. This sounds fast, but remember the distances. We are still hundreds of millions of light years away. The Great Attractor itself is difficult to observe. It lies in a direction known as a zone of avoidance, a region of the sky obscured by the dust and stars of the Milky Way. We are looking through our own galaxy, trying to see what lies beyond, and the view is murky, but we know it is there. We can measure its gravitational influence. We can see how galaxies move in response to it, and we can infer its mass, which is enormous, equivalent to tens of thousands of galaxies. The Great Attractor is not the only gravitational influence on the Milky Way. Beyond the Great Attractor, there is an even larger structure called the Shapley supercluster, one of the most massive structures in the observable universe. It, too, is pulling on us, adding to the cosmic flow. All of these gravitational pulls combine to create what astronomers call peculiar velocity. This is the motion of galaxies relative to the overall expansion of the universe. The universe is expanding, carrying galaxies apart. But within the universe, galaxies are also moving due to gravity, flowing along the filaments of the cosmic web, pulled by massive structures like the Great Attractor. The result is a complex dance. Galaxies expand away from each other due to the expansion of space, but they also flow toward each other due to gravity. The cosmic web is dynamic, alive, constantly reshaping itself. Think of it as a river. The expansion of the universe is like the overall flow of the river toward the sea. But within that flow, there are currents, eddies, whirlpools. Galaxies are like leaves floating on the water, carried by the main flow, but also influenced by local currents. The Great Attractor is one of those currents, a powerful one, a deep channel in the cosmic river, pulling galaxies together, guiding them along a common path. And we are part of that flow. The Milky Way, with all its billions of stars, with all its planets and moons and dust, is drifting through the cosmos, carried by forces so vast and so gentle that we barely notice them. Let us pause for a moment and consider the scale of what we are describing. Laniakea is 520 million light years across. This is so vast that it almost defies comprehension. If you could travel at the speed of light, the fastest speed possible, it would take you 520 million years to cross Laniakea. That is more than 100 times the age of the human species. More than the time since the first complex life appeared on Earth. And Laniakea is just one supercluster among many. There are other superclusters stretching across the observable universe. Each one is a river of galaxies. Each one has its own Great Attractor, its own flow, its own architecture. On these scales, individual galaxies become meaningless. Even the Milky Way, with its 300 billion stars, is just a point of light, a single pixel in a vast image. And yet we are here, on a small planet, orbiting an ordinary star, in the outskirts of an ordinary galaxy, in the immeasurable heaven of Laniakea. We are so small, and the universe is so large. But perhaps that is okay. Perhaps there is comfort in smallness. Perhaps there is peace in knowing that we are part of something so much larger than ourselves. So we rest here for now, suspended in the cosmic web. The Milky Way is a single point of light on a filament of dark matter. The local group is a small cluster. Laniakea is our supercluster, our immeasurable heaven. And beyond Laniakea, there are other superclusters, other webs, stretching across billions of light years. The universe is woven like lace, delicate, intricate, beautiful. We are being pulled by the great attractor, carried along in a cosmic river. Millions of galaxies flow together, moving at hundreds of kilometers per second, drifting through the immensity. It is a gentle pull, a patient flow, a river that takes billions of years to run its course. And in the voids between the filaments, there is silence, empty space, stretching for hundreds of millions of light years. Quiet, still, a darkness so complete that it feels almost sacred. As you drift now, as your consciousness dissolves into sleep, imagine yourself as a thread in this cosmic web. You are connected to everything. The atoms in your body were forged in stars. The gravity that holds you to the earth is the same gravity that shapes the cosmic web. You are part of Laniakea, part of the flow, part of the immeasurable heaven. The universe does not rush. It flows, it weaves, it turns, and you, resting now in the quiet darkness of your room, are held gently in its vast embrace. Sleep well, traveler. The cosmic web will still be here when you wake. It has been weaving for 13 billion years. It can wait another night. We have journeyed so far together, from our small world to the edge of everything we can see, from seconds to billions of years, from meters to billions of light years. And now, we arrive at the final horizon, the edge of the observable universe. Let your body rest completely now. Let every muscle soften. Let your breathing become so gentle that you barely notice it. There is nowhere left to go. We have reached the boundary. And beyond the boundary, there is only mystery. Tonight, we will explore the cosmic microwave background, the afterglow of the Big Bang, the wall that marks the limit of what we can see. We will learn about the observable universe and what it means to live inside a bubble of light. And we will discover something beautiful, that we are the universe looking at itself. We are the way the cosmos comes to understand its own existence. As we approach this final edge, you may feel yourself dissolving completely. That is perfect. That is exactly where you should be. Let go of everything. The universe will hold you. It always has. The universe is vast. We have seen this. We have traveled through billions of light years of space, through millions of galaxies, through the cosmic web. But there is a limit to what we can see, not because the universe ends, but because light has not had enough time to reach us. The universe began about 13.8 billion years ago in an event we call the Big Bang. Since then, it has been expanding, and light has been traveling. But light, even though it moves at the fastest speed possible, can only travel so far in 13.8 billion years. This creates a horizon, a boundary. Beyond this boundary, there are regions of space whose light has not yet reached us. We cannot see them, not because they do not exist, but because the light is still on its way, crossing the immense distances, traveling through the expanding universe. And at the very edge of what we can see, there is something remarkable, a wall of light, ancient, warm, a whisper from the beginning of time. In the beginning, the universe was hot, unimaginably hot, so hot that atoms could not exist. Matter existed only as a plasma, a soup of protons, neutrons, and electrons, all moving too quickly to bind together. And this early universe was opaque. Light could not travel freely through it. Photons, the particles of light, would scatter off the free electrons in the plasma. They would bounce and ricochet, unable to move in straight lines. The universe was a fog, glowing with energy, but impossible to see through. But the universe was expanding, and as it expanded, it cooled, like a gas released from a pressurized container. The universe grew larger and colder, slowly, steadily, over hundreds of thousands of years. And then, about 380,000 years after the Big Bang, something happened. The universe cooled enough for atoms to form. Electrons would have been zipping around freely, slowed down enough to be captured by protons. Hydrogen atoms formed. Helium atoms formed. And suddenly, the fog cleared. This moment is called recombination. It is the moment when light was set free. Photons, which had been trapped in the plasma, could finally travel in straight lines. They could move through space without scattering. The universe became transparent, and those photons, released at the moment of recombination, have been traveling ever since. For 13.8 billion years, they have been crossing the universe, and they are still here. We can still detect them. We call this light the cosmic microwave background, or the CMB. It is the afterglow of the Big Bang, a faint glow that fills the entire sky, coming from every direction. When this light was first released, it was hot. It glowed with the orange-red heat of molten metal. But the universe has been expanding for billions of years. And as space expands, light stretches. Its wavelength increases. Its energy decreases. So the light that was once visible, once glowing orange-red, has been stretched into microwaves. It is now invisible to the human eye, but we can detect it with radio telescopes. And what we see is extraordinary. The cosmic microwave background is remarkably uniform. It is almost exactly the same temperature in every direction, about 2.7 degrees above absolute zero. This uniformity tells us that the early universe was smooth, almost perfectly homogeneous. but there are tiny variations. Tiny fluctuations in temperature, less than 1 part in 100,000. These fluctuations are the seeds of all the structure we see today. The galaxies, the galaxy clusters, the cosmic web. All of it grew from these tiny ripples in the cosmic microwave background. The CMB is a wall, not a physical wall, but a wall in time. We cannot see past it. Before recombination, before the fog cleared, the universe was opaque. Light from that era was trapped. It scattered endlessly. It never escaped. So when we look at the cosmic microwave background, we are seeing the oldest light in the universe. We are seeing the universe as it was 380,000 years after the Big Bang. We are looking at the edge of time. The observable universe is the region of space from which light has had time to reach us. It is a sphere centered on Earth, extending about 46 billion light years in every direction. You might wonder why the observable universe is 46 billion light years across, when the universe is only 13.8 billion years old. Should light not have traveled only 13.8 billion light years? The answer lies in the expansion of space. While light has been traveling toward us, the universe has been expanding. The space between us and the source of the light has been stretching. So by the time the light reaches us, the object that emitted it is now much farther away than it was when the light was released. This is why the observable universe is larger than you might expect. Space itself has been expanding, carrying distant galaxies away from us, even as their light travels toward us. But here is the important part. The observable universe is not the entire universe. It is just the part we can see. Beyond the edge of the observable universe, there's more galaxies, more stars, more space. We live inside a bubble of light, a sphere of visibility, expanding slowly as light from more distant regions finally reaches us. But beyond this bubble, the universe continues. It may continue forever. It may be infinite. We do not know how large the universe is. We may never know. The expansion of space is accelerating, driven by dark energy. In the far future, distant galaxies will move away from us so quickly that their light will never reach us. The observable universe will shrink, not grow. But for now, we can see. We can look out across billions of light years. We can see galaxies as they were billions of years ago. We can see the cosmic web. We can see the cosmic microwave background, the afterglow of the Big Bang. We are inside a bubble of light, a finite bubble, yes, but a bubble that contains everything we have ever seen, everything we have ever known, everything we are. When we look at distant objects, we are looking back in time. Light takes time to travel. When we see the moon, we see it as it was 1 second ago. When we see the sun, we see it as it was 8 minutes ago. When we see Andromeda, we see it as it was 2.5 million years ago. And when we look at the cosmic microwave background, we see the universe as it was 380,000 years after the Big Bang. We are looking back through nearly the entire history of the universe. This is the horizon of time, the edge of what we can see, not because space ends, but because time has limits. Light has only had so long to travel, and before a certain point, the universe was opaque. There is nothing to see. In a way, the entire universe is a time machine. Every photon that reaches our eyes is a messenger from the past. When you look at a star, you are seeing ancient light. When you look at a distant galaxy, you are seeing the universe as it was billions of years ago. We cannot see the present state of distant objects. We can only see their past. The farther we look, the deeper into the past we see. And at the very edge, at the cosmic microwave background, we see the earliest moments we can ever observe. This is both humbling and beautiful. It means we are surrounded by history. Every direction we look, we see the past. The universe is a vast archive, written in light. For most of its history, the universe was dark and silent. There were no eyes to see, no ears to hear, no minds to understand. Galaxies formed, stars ignited, planets coalesced. All of this happened in silence. The cosmos existed, but it did not know itself. It simply was. And then, on at least one small planet orbiting an ordinary star on the outskirts of an ordinary galaxy, something extraordinary happened. Life began. It started simply. Single cells in warm water. But over billions of years, it grew more complex. Cells joined together. Organisms developed senses. Eyes evolved to detect light. Brains evolved to process information. And eventually, there was consciousness, the ability to perceive, to think, to wonder, to ask questions. We are the result of this process. Humans, conscious beings, made of the same atoms as the stars, made of the same particles that filled the early universe. We are stardust, arranged in such a way that we can look back at the stars and understand what we are seeing. In a very real sense, we are the universe looking at itself. We are the way the cosmos has organized itself to become self-aware. The atoms that make up your body, the neurons firing in your brain, the thoughts you are thinking right now, all of this is a universe experiencing itself. The physicist Carl Sagan said it beautifully. We are a way for the cosmos to know itself. Through us, the universe contemplates its own existence. Through us, it measures its own vastness. Through us, it wonders about its own origins and its own future. This is not arrogance. It is not claiming that humans are special or central. We are not. We are small. We are brief. We occupy a tiny corner of an unimaginably vast universe. But we are here, and we are aware, and that is remarkable. Out of the chaos of the Big Bang, out of the formation of atoms and stars and galaxies, out of billions of years of cosmic evolution, consciousness has emerged. The universe has developed eyes. There may be others, other worlds where life has arisen, other beings who look up at their own night sky and wonder. We do not know. We have not found them yet, but the universe is vast, and life, once it begins, seems eager to persist, to adapt, to grow. Whether we are alone or one of many, the fact remains, we are here, we are conscious, and through us. What does it mean to live inside a bubble of light? To stand at the edge of the observable universe, knowing that there is more beyond, but unable to see it? Perhaps it means that we should appreciate what we can see. The stars, the galaxies, the cosmic web, the ancient light of the cosmic microwave background. All of this is within our reach. All of this is part of our bubble. Perhaps it means that we should be humble. The universe is larger than we can ever know. There are regions of space we will never see. There are galaxies whose light will never reach us. We are small. Our knowledge is limited. But perhaps, most importantly, it means that we should be grateful. Grateful to exist. Grateful to be conscious. Grateful to be able to look up at the night sky and understand even a little what we are seeing. The universe did not have to produce life. It did not have to produce consciousness, but it did. And here we are, the eyes of the universe, looking back at the beginning of time. So we return now from the edge of the observable universe, from the cosmic microwave background, from the wall of ancient light. We return to our small world, our quiet room, our warm bed. We have traveled so far, from the solar neighborhood to the Milky Way, from the local group to Laniakea, from the cosmic web to the edge of everything we can see. And now we rest. You are made of stardust. The atoms in your body were forged in the hearts of ancient stars. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it came from the cosmos. You are the universe experiencing itself. You are the way the cosmos knows itself. You are small, yes, but you are also magnificent, a conscious being, able to contemplate the vastness, able to understand your place within it. As you drift now into sleep, as your consciousness fades into dreams, know that you are held by gravity, held by the fabric of space-time, held by the gentle, patient turning of the cosmos. The cosmic microwave background glows softly in every direction. The galaxies flow along their filaments. The local group drifts through space. The Milky Way turns. And you, here in your quiet room, are part of it all. There is no rush. There is no urgency. The universe has been here for 13.8 billion years. It will be here long after this night has passed. Rest now. You have traveled far enough. You have seen enough. Let the darkness hold you. Let the silence surround you. Let yourself dissolve into the quiet immensity of the cosmos. Sleep well, traveler. You are the universe, dreaming of itself, and that is beautiful. Good night.